Hey guys, welcome to Concept and Coding, and this is Shreyansh, and today we are going to start multi-threading, and these are the list of subtopics which I have come up with. So I'll go with this list itself so that we don't miss any topic in the multi-threading and concurrency, right? Don't worry, I will post this the list into the description section so you can refer it, and I'll complete this in parts. So in today's part I will cover this too. So this is the part 1 video of it. Okay, so let's start our multi-threading and concurrency part 1. Okay, so introduction of multi-threading. So before we talk about multi-threading, right, or what are the different threads and all, we have to first understand what is thread and what is process. This is one of the most asked interview question, and don't underestimate this question because I have seen many good engineers getting stuck into this question, right? Because there are so many follow-up questions can come into this, and at one point engineer do get stuck, as this is very important questions and lot of logics are building around it, right? So let's see that how actually they are differs and how they are actually related. What is thread and process? So just look at this diagram, you will get one glance that okay, we have a process, and inside a process we have multiple threads, right? And that's where you will find the definition across all over the internet that process is instance of a program that is getting executed. Yeah, let's read it again. Process is an instance of a program that is getting executed. Now what does it mean? Okay, what do you mean by that program that is getting executed is called process? I'll tell you what does it mean. Suppose that you have one Java file, test.java. This has your public static void main string args, right? And you have your code. Now what the first thing you have to do, if to have to run it, you have to do compile it. You have to do java c test.java, right? The first step, compilation, java c test.java. What it will do, it will generate the bytecode that can be executed by the JVM. Now the bytecode which is generated by it, now we have to execute it. How we will execute it? We have to run it like java test, right? When we will do executed, what we will do, JVM starts the new process at this point of time. So that's why the name, or you can say the definition of process, says that it is an instance of a program that is getting executed. So now here if you see, we are executing our program. After we execute it, whatever the output has to become, you will show into the console, right? So whenever you are doing execution your program, at that point JVM starts the new process, right? And that's how generally the definition which says that a program that is getting executed is known as process. But generally it is not known as process, it is generally at that time process is created, right? So there are lot of things is required when a program is getting executed. It required lot of resources like memory and all, right? So process provide all these things, right? So we will see soon at that point also. So this first step is clear, right? Process is an instance of a program that is getting executed. Second, it has its own resource like memory, thread, etc. OS allocate these resources to process when it is created. So I told you, right, to execute a program, it required a lot of resources like memory. So OS takes care of allocating these resources to process. So now what happens is, okay, you are executing a program, JVM creates a process, right? I have a process 1. This process required certain resources like memory also. So what happened is, it has its own memory, let's say heap memory, So when, let's say, another process is getting created, process 2, it has its own memory, its heap memory, right? So these two processes are totally independent of each other. They have their own memory, right? And they don't, like, you can say that they don't disturb each other. They can run parallelly, right? They are totally independent of each other. I know that at this point of time there are a lot of questions coming into your mind that, hey, how this process have their own heap memory? Because we understand that JVM has their own one heap memory. JVM has heap memory. It also maintains a stack, right? Now how this process have their own heap memory? Don't worry, I will come to everything. I know this is where all things get messy, right? But we are taking a baby step. First you need to understand what is process. So process means whenever you execute a program, a process is created. Each time a process is created, it has allocated its own resources. They never share, two processes never share resources to each other. They have their own resources and they can run parallelly. Okay, so we have this basic understanding of process. Don't worry about this, I will come to this later. Now what is thread? Okay, I understand very basic of process now. Now can you tell me, like, what is thread? With this diagram we can tell that one process can have multiple threads, right? Okay, that's right, one process can have multiple threads. But thread is also known as lightweight process. But what does it mean? It means the smallest sequence of instructions that are executed by CPU independently, right? So whenever we have, so what does process do? Process, like, it is converted the bytecode into machine code, right? You have converted the bytecode into machine code. Now this machine code has to be executed, right? This has to be executed by CPU, right? This machine code has to be executed. This machine code is nothing but a sequence of instruction. So what is thread? A thread is the smallest sequence of instruction that are executed by the CPU independently. There can be multiple threads. So let's say these sequence of instructions are executed by this thread. This sequence of instructions are executed by this thread. This sequence of instructions are executed by this thread. So that's what thread says, that smallest sequence of instructions that are executed by CPU independently. Okay. When a process is created, it starts with one thread, and that initial thread known as main thread, and from that we can create multiple threads to perform tasks concurrently. Now let's understand this. So here, if you see, this is a very basic Java class. I have created a class, given a class name multithreading learning, and I have put a method public static void main string args, and I am just printing out this thread.currentThread.getName. So now when the first I did Java C multithread learning.java, it will convert to the bytecode. Now after that I will do Java multi-threaded learning. What it will do is it will execute it. So what JVM will do is it will create a new process, right? Because this bytecode has to be converted to machine code, right? And that machine code need to be run by the CPU. So it has, they need a process. It required a lot of memory also. There are a lot of resources required. So it is just, you can say that interface to us. Hey Java and the class name. Now you get the output. But at the back, there are a lot of things required to convert bytecode to machine code, and from machine code it has to be submitted to the CPU, and CPU has to run it, and then we will get the output, right? So all is taken care by the process. So now when you are executing this class Java multi-thread learning, what will happen is a process is created. A process will have its own memory, let's say heap memory, and one thread will automatically get created. right? And that thread is known as main. So here if you see that I am printing system.println thread name, thread.current thread get name. What it printed? Main. So that's what it says, that when a process is created, it starts with one thread, and that initial thread is known as main thread. So automatically it will create one thread that is known as main thread, and from that we can create multiple threads to perform tasks concurrently. So let's say this is your program, right? You have, this is your main thread. Main thread is running. Now you can create thread 1 and which can perform certain tasks. You can have thread 2 which can do certain tasks, and then after that again you have sequence of instruction which is again followed by main thread only, right? So whenever you execute a code, a starting point, it process will create one main thread and start executing the code, and from this main thread you can initiate more threads, right? So one process can have multiple threads, right? Process 1, thread 2, thread 3. So first of all, is process and thread is basic definition is clear. We will now go level deeper, but first you have to understand when does the process get created, right? And what is actually process is, right? So whenever we try to execute a program, process is created. Process is nothing but, you can say that it takes care of like execution of the program. The execution of the program required memory, right? They are converting byte code to machine code. There are so many things happens, and we have to submit to the CPU, right? So there is a process. After this step, go to this step to those step. That is known as process, right? So whenever we try to execute a program, a process is created, and each process has multiple threads, and thread is nothing but a smaller sequence of instructions that are executed. Okay. So now if the basics is clear, let's understand little bit more about process and threads, right? So here is the diagram. There are so many things. I'll try to go in depth of each. So first, understand that JVM, like if you remember our initial video, right, where we have discussed about memory management and garbage collector, I have told you that JVM has it has heap, it has stack memory also, right? So JVM has lot of memories. So here, if you go a little bit more depth, JVM has heap, stack, code segment, data segment, it will have registers, it will have program counter, and there are others. So these are all memory areas, right? Heap and stack is just one where you required garbage collector concepts. But apart from heap and stack, there are so many other memory also, like code segment, data segment, register, PC, right? So JVM has all of this. Now, why I'm telling you all of this now? So understand this, right? When we are executing a program, Java, let's say your main class, Java main, right? We know that it will execute your program and you will get the output. But how internally it works, how it creates a process where it will execute the code, that we have to understand. So what is the first step? So first step is it will create a process. It will create a process. Second thing is a new JVM instance. A new JVM instance is created. So here if you see that the JVM has so many memories. So whenever a process is created, whenever a new process is created, you can say that a new JVM instance is allocated to that process, right? Because to execute a program, you need certain memories, right? So JVM provide those, right? So whenever a new process is created, a new JVM instance is created and allocated to that process. And JVM instance has all this memory. So that's you can see in this diagram. So now let's say the process is created. Let's say this is the process which is getting created, right? This, so for process 2, this is the process which is created. Now for each process, a new JVM instance is created. So here, let's say a new JVM instance is created. So this is process 1. So for it has JVM instance 1. This is process 2. For it has JVM instance 2. Different, right? And each JVM instance has all of this memories. It will have heap memory. It will have code segment, data segment, register, stack, counter. Right? Now you can, the questions might be coming into your mind. Hey Shansh, you have initially told that JVM has, let's say, heap size. Let's say its heap size is 10 GB. Assume that, right? This heap is 10 GB. Now, whenever a new process is created, a new instance is given, a new JVM instance is given to a process, right? And with that, a heap memory is also allocated to that process. So how much heap memory is allocated to it? Is this process is allowed to use the complete heap of 10 GB? How much they can use a heap, right? This JVM instance is allowed how much heap? So we can define. So whenever we create a process, so when does the process is created? When we do Java this. So here we can do this thing. So this is generally how we run Java and your class name, right? So generally here, if you see that we haven't defined like how much heap memory they can use, but we can tell that like this. So -x ms, which is for minimum, and the size. So this will set the initial heap size. So let's say I allocated 256 MB. So you can do that like this: -x ms 256 M. And if you want to allocate the maximum heap size, you can do -x mx size. -x mx, I said 2G, which is for 2 GB, right? So whatever the process will get created, a new JVM instance will be allocated, and this JVM instance will use this to operation and allocate a minimum heap size is 256 MB and maximum it can allot is 2 GB only if required. And if process is required to allocate more memory, right, out of memory error will come. Even though the JVM heap has, let's say, 10 GB overall, this has 10 GB overall, but whenever a particular JVM instance is created, we will allocate that whatever we have tell at the time of process execution, program execution, that hey, mx, let's say only 1G, so only 1 GB. For this another process, I can say that okay, 2 GB, right? But whatever the heap memory is being used, it is used out of this 10 GB only. Like, so no matter how many JVM instance you can create, let's say if there are 10 process, 10 JVM instance, right? And if they are using heap memory, so this heap memory is allocated out of this 10 GB only. That whatever the total JVM heap memory is allocated to the JVM. So first thing is clear. It create a process, and with each process a new JVM instance is created, right? A JVM instance has all this memory space: heap memory, stack, code segment, data segment, register, PC, like this. And how they are divided. So now let's say that we have 3 threads. I told you, right? In a process we have multiple threads. So now let's say we have 3 threads: thread 1, thread 2, thread 3. So now register, stack and counter, they are locally to each thread. Threads do not share that to each other, right? They do not share to each other. So this three thread, what they do share this code segment. So here the code segment is shared among all these three threads. Data segment is shared among all these three threads. Heap memory is shared among all these three threads. But register, stack and counter, they are local to each thread. Then let's now first understand what is the use, then we will try to see how this all comes into the picture, right? So now let's see, first understand what is code segment. So code segment contains the compiled bytecode, machine code of the Java program. So you have this, let's say, main.java file. You have this main.java file. What is the first step you do? You have done compilation javac main.java. What it will generate? Bytecode. Now when you want to execute it, what you will do? Java main. So now what will happen is, it will create a process, it will create a JVM instance, right? And also one more thing will happen is, it will initiate, right, JVM. Now you can say that when the JVM instance is created, now JVM, what it will do is, it will interpret it or use the JIT compiler to convert this bytecode to machine code. Machine code is generated, right? So when you run Java when you execute this program, first process will get created, second JVM instance will be allocated to that process. This JVM instance use its interpreter or JIT compiler to convert this bytecode to machine code. So this code segment actually stores the compiled bytecode, or you can say that the machine code, which CPU understand, this machine code. So that is stored here, code segment memory. What is data segment? Data segment stores the global and static variable. So inside your code, if you have global variable or static variable, so these are shared among all the threads. So all those global data and static data are stored among data segments. Okay. Then we have a heap. Heap is, so here one thing I have forgot to tell you, in the code segment it is read only, because once you get the machine code you can't change it, no thread can change it, they can just read that machine code. Data segment is, they have global and static variable. Threads can read and modify the same data. So we need a proper synchronization between threads, because threads can change the data which is present into data segment. So proper synchronization is required. Then heap. So when these threads are getting executed, they will definitely create new objects if required. So whenever they use a new keyword, new objects are allocated a space into the heap. They are allocated a space into this heap. Heap is shared among all the threads of the same process, but not within process. So what I mean is, these three threads have this access to this heap memory, but this process do not share this heap memory. So all the address which this heap is pointing to is totally different from this heap, right? So ultimately they will go into the different address into the main memory, like main different heap, right? JVM has the main heap memory. So ultimately they all get mapped to a different location. So they are totally different heap memories. Process 1, process 2 do not share the memory locations, but this thread 1, thread 2, thread 3 inside a particular process is sharing this heap memory. So heap is, right, thread can read and modify the heap data. Synchronization is required between multiple threads for the heap. Whatever the data is present into the heap, the threads can change it also. Okay, so now you have cleared what does code segment store, what does data segment store, what does heap store, right? And heap size can be differed between process to process. Now let's understand register, stack and counter. Stack, you know, right? Each thread has its own stack. It manages method call local variable. In the first memory management garbage collector, I explained stack, how stack is maintained. They maintain local variables and all. So each thread has their own stack. Then we have register. So now what is the use of register? So you see that CPU also have register. They also, JVM also has a register. So this register is used to store some intermediate values, right? So JVM, like whenever you execute, so whenever we convert bytecode into machine code, right? Sometime we have to like reshuffle the instructions, right? And there are certain immediate values. So all those are stored into the register itself, right? So this register is used, right, whenever the JIT uses it, like whenever it convert the bytecode into machine code, right? It uses register to optimize the machine code, generated machine code, because machine code instructions can be reshuffled. Some intermediate code has to be stored, right? So that is stored inside this register only. And it also helps in context switching. I will tell you how. Very, very important. Each thread its own register. So each thread has its own stack, each thread its own register. And let's understand what is counter. So there is something called counter, which is also known as PC, which is program counter. It points to the instruction which is getting executed. Increment its counter after successful execution of the instruction. This is very, very confusing part, right? Points to the instruction which is getting executed. So I told you that code segment has the machine code, right, which has to be executed. Each threads are running, you can say that some part of the code. What part of the code they have to run? The counter points the address of that instruction in the code segment. Okay, you have to run this part, you have to run this part, you have to run this part of the code segment, right? Don't worry. Now let's see how this is totally done and where this is the physical CPU comes into the picture. But at least you got the concept, right? Code segment, data segment, your stack, register and counter. Counter, like machine code, native machine code is present into code segment which CPU understand. Counter just holds that this thread need to run this instruction. This thread need to run this instruction. So all this counter point the address to this code segment instruction, which code this thread has to run. But how? Now let's understand one complete flow. Okay, first I have written one Java code, let's say main.java, right? And what will happen is I have certain code and then we have some piece of code which is executed by thread 1. Let's say this is main thread, and from this I created thread 1 which is doing this part of code. Then we have thread 2 which is doing this part of the code, and then again after that this. Let's say I have written some code like this, right? So I have started executing of the code, then I've created two threads which is doing certain specific task, and after that main thread is again resuming it. Okay, now what I have to do is first java c main.java. Now what will happen is the bytecode will get generated. Now second, I am executing it java main. Now when I am executing it, what would happen is process will be created. One process will be created. This process will be created. Now once the process is created, what it will do is JVM instance is allocated. JVM instance is allocated, right? So it also allocated this JVM instance to a process, right? And JVM instance will have heap memory, let's say defined by here we have defined our xmx, let's say 1 GB I have allocated this one, right? So I have initiated the JVM instance, and this has code segment, data segment, right? So currently it doesn't have the threads right now. So now what it will do is this JVM will start doing interpreting or JIT compiling, just in time compiler will start converting the bytecode to machine code. And while it is converting this bytecode to machine code, it knows that, hey, I have thread 1, thread 2, the 3 threads are required. Main thread, thread 1, thread 2. So what it will do is, it will create 3 threads, right? And for each thread, it will assign a stack, register and counter. So for each thread, stack, register and counter will be assigned by the JVM scheduler. So, okay, so it created 3 threads. After, while converting it to this machine code, right, it get to know that, okay, I need 3 threads for this executing this main thread, then thread 1, thread 2, right? And it will assign this machine code, like from this machine code it will create this 3 threads, and 3 threads will have this register, stack, counter, right? Now whatever this machine code is generated, right, it will save this machine code into code segment. So this now code segment has the machine code which is generated. So this will have the machine code which CPU understand. This will have the complete machine code of this. Okay, now this counter will point to an address into this machine code. Let's say this is thread is for this one is main thread. This thread 2 is, let's say, for T1, and this thread is T2. Okay, so this, let's say T1 is executing this, right? So its counter, program counter, is pointing to an address where in this machine code this getting started, right? Similarly, the thread 2, let's say these are the code thread 2 has to execute. This program counter has the address on the machine code, the code segment memory, where the thread 2 has to start executing. You got it? So they have the counter, program counter has the address of the code segment where these threads have to start working. Okay, so this is also done. Now we have to start execution of this. We have to start execution of this program, right? So who will run the program? JVM doesn't run the program, right? CPU has to execute this machine code. So what we'll do is this thread, right? So what happen is that this thread, this register, it uses this register. So it is very similar to CPU register, right? So what will happen is, let's say, understand that you have only one CPU. You have only one CPU. It has only one register, right? It has its cache and RAM. Let's say that you have only one CPU, one core, nothing. There is nothing like a 2 core. It's only one CPU, right? Now we have 3 threads. Now what will happen is the 3 thread has to, now they have the machine code. Now they have to run. So what we'll do is, let's say main thread start running it. So what main thread will do is that it uses the register, right? It will store the data and it will assign it to the CPU, right? So CPU, what it will do is it will start executing this main thread. So who takes care of assigning this to CPU? So the OS schedule, or you can say that manage these threads. There are like sometime OS, and there we also have JVM schedulers also. So OS itself manage JVM schedulers. So that's why we say that OS schedules these threads which need to be executed, right? So all these threads which has the program counter, like it is pointing to machine code, now they are just waiting to get executed. Now OS will schedule it, that, and what they will do is they will assign it to the CPU, right? Hey CPU, run their code. Now what CPU will do is that, and from this program counter, like it will load this machine code into the memory. So here in the register it can load, and it will provide to the CPU. CPU will now start executing its machine code, right? And CPU can use this register to store the intermediate results and all. So it can start executing this, right? Now let's say that each thread OS has given a time of, let's say, okay, 1 second you can run. After that you have to wait. Somebody else has to run. So because there is only one CPU. Now let's say main thread was running, right? So it, from this program counter, it loads the machine instruction. Machine code has a sequence of instructions. So it load the instruction which this thread has to execute, right, into the register. You can say that it's a kind of a virtual memory register. Now OS will assign it to the CPU. Hey, you executed. Now that instruction is read by the CPU and it will start executing it. It will use its register to store the intermediate result and all. But while it is processing it, let's say 1 second is completed. Now what it will do is it will have to do context switching. Context switching, very important. So context switching means now what it will do is all the results which CPU has generated, let's say till 50% CPU has completed. So whatever the 50% data CPU has completed, in this register it will get stored, and OS will now run another thread. Hey main thread, whatever the CPU has run, you store in your register and you wait. Now I am running thread 1. So now let's say thread 1 is running. So now thread 1 is running, let's say after 1 second, thread 1 also time completed. Let's say thread 1 completed 70%. So what it will do is all the intermediate data from the register and whatever the CPU has completed, it will put into its thread 1 register, and it will do a context switch, and it will now start thread 2. Right? So like this. So when let's say thread 1 or main thread turn comes again, let's say thread 1 turn come again. So what it will do is it will use its register, load it back again, and start from that itself. So thread 1 was completed, let's say 70%, right? So all that 70% data is present into register. So when its turn again come, it will put into the register back CPU, and CPU start from where it left, right? So that is known as context switching, right? So this is the term, this is the scenario when we have only one CPU. Now let's say we have multiple CPU. Let's say we have multiple CPU. So when we have multiple CPU, it is that CPU, this CPU 1 is running thread 1, this CPU is running thread 2. So they are actually running parallelly. When we have multiple CPU cores, it is possible that two threads can run actual parallel. If CPU cores are 2 and there are, let's say, 20 threads, thread 1, thread 2, thread 3, thread 4, thread 20. So definitely we have to do context switching. Like it first run this, then it run this, like so each will do context switching, right? So context switching means they are not actually running parallelly. but it looks like they are run parallelly, like all are running simultaneously, it looks like, but internally CPU is doing context switching, right? But let's say if you have two CPU core, or let's say four CPU core, CPU1, CPU2, CPU3, CPU4, and let's say you have three threads, thread 1, thread 2, thread 3, all thread 1, thread 2, thread 3 can run actual parallelly. They are actually running parallelly, no context switch is required in that case. So you got it? So this machine code, how this code segment and this program counter are related, right? You got right? So each one is pointing, program counter is like where this thread has to start executing, and it will keep on incrementing as soon as this instruction is successfully completed by the CPU. Okay, so program counter will keep on increasing its counter, like whatever the code this thread has to execute, whatever the code this thread has to execute, this counter keep on executing, counting it, the address, it will point to the address where the next instruction has to be loaded from this machine code. So here if you see that the code segment is same, all these three threads are just using this counter address from this code segment which has the machine code, and it just tells the CPU that hey, read this instruction and execute it. So that's why they are actually doing things parallelly, right? Sometimes if CPU is less, there are more threads. Parallelly in the terms is context switching. It looks like they are working parallelly, but actually it's not. But sometimes when the CPU cores are more and thread is less, it actually runs parallel. So this is clear totally how the process threads are actually run, right? So code segment, data segment, heap, stack, register, counter should be super clear, right? I told you, right? Register helps in context switching. How? You got it, right? Because let's say if time up happen for the particular thread, OS will take all the intermediate data from the CPU and put it into its register, and it has to wait. Next time when it will have to come back, it will use its register, put it back to the CPU and start from there itself. Now you have know about process and threads. Now let's understand definition of multi-threading. So now can you explain it? Multi-threading is allow a program to perform multiple tasks at the same time. Right? Multiple operation at the same time you can do. Right? Instead of task, I would say that multiple operations at the same time itself. Multiple threads share the same resource such as memory space, but still can perform tasks independently. Right? You got it, right? They do share a common resource like code segment. They do share this data segment. This is the memory they share. Heap memory, they also share this. Right? But they also have some independent memory which helps them to run individually. What are the benefits and challenge of multi-threading? Benefit is improve performance by task parallelism. So definitely by the task. So let's say if you have two CPU, right? So if you have thread 1 and thread 1 has to perform all the instructions sequentially. So only one CPU will do. So with parallelism, you can do two threads, thread 1, thread 2. You can divide the task, sum of the task to it, and they can perform parallelly, right? So it perform the performance by task parallelism. Responsiveness, definitely it brings the response faster to the clients, right? Performance improve, definitely the output result or responsiveness of the application will get improved also. Resource sharing, this multi-threading, they are utilizing the resource very well. So here if you see, they are doing resource sharing. So they are utilizing the resource very well, right? So resource sharing also you can say that it's a benefit, like it's not that much expensive because they do share the resource. So resource sharing is also a benefit that yes, multi-threading allow you to share the resource between multiple threads. But there are few challenges. First challenge is that concurrency issue. Like since they are accessing the same resource, like heap memory, I told you data segment, there are global variables and all. It is possible that deadlock, data inconsistency can happen. So we have to handle that. And how to handle that? Through synchronization. And that is an extra overhead. We have to put lock, synchronize block. That is an extra overhead. And sometimes multi-threading make our code difficult, and testing and debugging is difficult, right? So I'm not sure in live have you faced this not. I have faced this. Because of this concurrency, sometimes it's very get difficult to debug it, because there is no test case written, as it is difficult to test in local itself. So these are the few challenges which I thought. And before last, there is sometimes confusion happen, or interview asks what difference between multitasking versus multi-threading. So here the question answer lies here itself. So process 1, process 2 is multitasking. This is task 1, this is task 2, right? So this is known as multitasking. And inside a particular task, we can create multiple threads. That is known as multi-threading. In the multi-threading, they share the resources. In the multitasking, they do not share the resources at all, right? So here if you see that in the thread, each 3 threads share this heap memory, share this code segment, share this data segment. But this task, multitask, they never share any resource. Code segment is also different, heap memory is also different. All the resources are different, right? That's the only difference. So different process is known as, you can say that, different task, right? And inside a particular process, we have multiple threads, and when they are executing, that's called multi-threading. And when the program execute multiple process, like by context switching, that is known as multitasking. Okay, multitasking, they do not share any resource, but inside the multi-threading, threads do share the resource. Okay guys, so I think it should be clear. This totally should be understand properly, like how context switch happen, how this JVM helps the processes, right? So all these things should be clear. And yeah, next we'll see the how to create a threads in Java. Okay guys, thank you, bye.